In Algebra 2, section 8.2, we're dealing with adding and subtracting rational exponents. So basically what you're dealing with this section is adding and subtracting fractions. And when we add and subtract fractions, it's important to remember that we need common denominators. Now, unlike, I'm just going to put this down just to explain to you, when we have 3 to the 12th plus 4 to the 4th, I have to turn this into 12, and it will come down before I add the numerator, right? But in our section, we're dealing with rational exponents, so we have equations. So you're probably going to deal with like x plus 2 over x plus 3 plus x plus 4 over x squared plus 2. These kind of things where, in order for me to add the top, I have to find a common multiple of these two and find common denominators. So that's just to give you a little bit link of prior knowledge. So basically we're just adding and subtracting, trying to find common multiples. The only hard part is that we have to find that common denominator, and it's a little bit more difficult with equations, with rational expressions. So the first thing is we need to find least common multiple for the denominator. So we need to find a common denominator, and then we add and subtract the numerator. But if I'm changing the denominator, anytime I change a fraction, whatever I do to the bottom, I have to do to the top. That's important to remember. What you do to the bottom of a fraction, you do to the top. So before we actually go to fractions, let's get some experience in finding the least common multiples. So if I'm pretending that these are all denominators of a fraction, then I'm going to find out, I need to find out what common multiple. So I'm not dealing with just numbers, I'm dealing with variables. So in order for me to find a least common multiple, I'm going to factor to see which factors they're missing. So if that's confusing, bear with me. 15 deals with 3 and 5, and 2 A's, a B, and 3 C's. Okay? 16 deals with an 8, a 2, a 4, a 2, a 2, and 2. B is 5 B's, and C is 2 C's. This is a 5 and 4, 2 and 2, 3 A's, and then 6 C's. Okay? This is our factoring. So I'm going to focus on these numbers, 15, 16, and 20. And what I'm going to do is I'm going to put them in factorization. So this is 3 times 5. This is 1, 2, 3, 2 to the 4th. 1, 2, 3, 4. And this is 2 to the 2nd times 5. So what I'm going to do is, once I figure out this for the numbers, is the same thing that I'm going to do with the variables. I'm going to choose the factors with the greatest degree. So I need to have a 3, right? So I'm going to do it right here. I need to have a 3. And then this has, I need to have a 5. And then I need to have 2 to the 4th. This would cover also 2 to the 2nd, because I have covered 2 to the 2nd and then some, and I've also covered a 5. So this would give me 3 times 240. Okay? And just like what I did here, I'm going to take the biggest factor. So I have a to the 3rd, which takes care of this a. This has no a, and a to the 2nd. B to the 5th. This has no b, so b to the 5th. Sorry, I'm running out of room. And then last is c to the 6th. So I'm seem like a lot of work to put in factors, but if not, I'm going to have to be taking 15, 16, 20 and thinking, what number does all three go into? If I multiply them all together, the number is going to be in the thousands. So for me, I break it down to factors, and I just take down each of the largest factors, the largest power of the factors in the 3, and it should include it. So all of this, it goes into a third, because even though this doesn't have an a, if I multiply a to the third, it'll be fine. 240, each of these are divisible by 240 because it has all the factors in it. And so this becomes my lowest common multiple. Now, if I end up, again, like when we're looking for common denominators, and I get up not the lowest common multiple, but it's still a common denominator for all equations, that's perfectly fine. But I'm trying to minimize the big numbers that you're dealing with. So for these ones, I have to break it down. And you've seen it before. This is, we're going to see if they have anything in common. So this one I can take out an x, and I end up with x squared minus x minus 2. And then I can go, two numbers when multiplied together gets me -2, but when added together gets me -1. I'm thinking it's -2 and +1. And then this one, there's nothing that all three have in common. So I'm going to find two numbers when multiplied together gets me +4, but when added together gets me -4. This is both -2. And again, I'm going to take the factors, the highest factors of what they have. So this one is the same thing as x minus 2 squared. So I'm going to take this whole factor because that has the biggest. And that includes this, and then I have to also then include this because the other one doesn't have it. Now, I don't need to multiply it out. This can just be my common denominator. And when I'm dealing with finding the common denominator, it's easier just to keep them in bubbles until the very end. So, hopefully that made some sense. And of course, if not, we'll go into class and go over the problems. But go ahead and pause this and write this down. And we're going to now try actual fractions, and I'll see what you mean. These are just practicing to find the common denominator, that lowest common multiple. Oops. All right. So number 2 is more like the first one. Oh, I named number 2. Okay, so number 2, again, what I'm focusing on is just the denominator right now. And I'm going to factor them. 6b factors into 3 times 2 times b, and then 14a squared, b squared factors into 7 times 4, which 4 can be 2 squared, a squared, b squared. And just like we did in the last section, I'm going to take the biggest factor of each of the common. So I need a 3 and a 2. Well, this is the 2. This 2 is with this 2, so 2 squared times 7. And then I need an a squared. 7's already taken care of. And then since this is b, this b squared wins. Times b squared. So my common multiple would be 4 times 3 is 12 times 7, 84, a squared, b squared. Now this is what you did in the last problems, but from there I have to figure out what I need to do to actually change that. So I'm going to use this and I'm going to start comparing it to the factors. In order for me to turn 6b, which is factored into 3 times 2b, I have to multiply 6b by, it already has a 3, it has 1, 2, so I have to multiply it by another 2, I have to multiply it by another 7, it has no a, so I have to multiply it by an a squared and 1b. Do you see what I mean? what factors is this missing that I have to multiply? Because whatever this is, that's what I have to multiply the top and bottom. And I have to do the same thing here. What is missing here? Well, in this case, it has a 7, it has a 2 squared, it has an a squared, but it doesn't have a 3 or a b squared, so 3 times b squared. So this is what I need to multiply the denominator in order to match my LCM. The reason why I need to know that is because that's what I need to, if I'm multiplying the bottom by this, which is 14a squared b, and remember our rule is what I have to do to the bottom, I have to do to the top. 14a squared b. This is then 3b squared. I have to multiply by that. So my new fraction, hopefully it'll fit here, 14 times 5. So we have 70 a to the 4th b over 84a squared b squared plus 3ab squared over 84a squared b squared. So in this case, I'm going to need some space. So it's 70 a to the 4th b over 84a squared b squared plus 3ab squared over 84a squared b squared. So now once I have that, then I can do under 1 and combine this, which is 70a to the 4th b plus 3ab squared. The reason I want to do that is because now I can take out what they have in common. 70 is not divisible by 3. There's no factors in 3. It's okay. So I can't take anything, but I can take out an a, and I can take out a b. So then this will leave me 70a cubed, no more b, plus 3 no a and just 1b over 84a squared b squared. And because this is being multiplied, then I can reduce. Because with this plus, I can't just reduce what this has in common because that plus gets in the way. But anything on the outside that they both have in common, I can take out. So this cancels out, and this just leaves me with a in the bottom. This cancels out just b. So my final answer is 70a cubed plus 3b over 84ab. And this is my answer. Ooh, that was a long one. So go ahead. I'm going to put this up here so you can pause and write this down. And then you can pause and write this down. Okay? Just remember that what we're doing is basically we're trying to find a common denominator. And once we find a common denominator, then we can combine the numerators and reduce from there. So let's look at number 3. Use this black to kind of help me focus here. So, same thing with this one, these. I'm going to find what they have in common. So I can't put them into 2 bubbles like I did the other one. So I would take out a 3. We would do x minus 5. And then this one would be 6. And we would do x minus 30. minus 5. Right? Yes, 30, 15. Perfect. Okay. So we have to figure out what they both have in common. We need to have a 3. Well, actually, this 6 is a 2 and 3. So I need a 2, because this doesn't have it, and 1, 3, and then 1x minus 5. So 6x minus, 6x minus 5. This is our LCM, our lowest common. So if I wanted to do that, I would then figure out how to make each of these 6x minus 3. Now, this 6x minus 5 is the same thing as this. Because it's the same thing, I'm just going to rewrite this whole thing. 3x plus 15, and then 6x minus 30. Because I'm not going to change anything, because this can be turned into this, because this is our LCM, our lowest common multiple. Now, in order to turn this one, the only difference between this and this is a 2. We need to multiply this by 2, and what I do to one side, I have to do to the other. Now, remember, when I'm multiplying by 2, I distribute it, because this one I didn't have to, because there's no plus or minus in each of the numerator and denominator. This one does. So if I'm multiplying just by 2, it doesn't matter. I have to take that 2 and distribute it. So I end up with 2x plus 20, and I should end up with exactly this. 2 times 3 is 6x, 2 times negative 15 is negative 30. If these are not the same, I can't move on. All right? Once that they are the same, then I can put them into one fraction. 2x plus 20 minus 3x plus 15 all over 6x minus 30. Now I can combine like terms. 2x and minus 3x is negative x, and then 20 plus 15 is plus 35. And I want to keep this as a factor, and here's why. Oh no, hold on, can I, is anything in common? Yep, that's it. So 6x minus 30. Because if I could take something from the top and take it out, and I'd be able to reduce, but because I can't reduce negative x plus 35 any further, this then becomes my answer. So basically I keep going until I can't reduce anymore, and this becomes my simplified version. So go ahead and pause and write this down. This is actually a pretty long one, and it might be overwhelming to do it on the video, so we'll do it in class, or you can see if you should try it. But either way, you should try page 541, 410, and 14. So pause and write this down. Try page 541, numbers 4, 10, and 14, and then we'll finish number 4 in class. So I will see you in class.